Welcome all. Through this video, we shall familiarize with the polar plots. The syntax for polar graph is polar inside parenthesis theta r and optional keyword arguments. Theta and r are sequences like list or can be arrays also. Theta is a sequence of angles and r is a sequence of distances from the center. Like in plot function, you can have multiple polar graphs by adding multiple theta and r arguments, just like as in plot function. Now let us describe how a polar graph is plotted. So to plot a polar graph, we need two sets of sequences, namely theta, that is angles, and r, distances. Generally, a particular theta and r is represented like this. So this is the idea. X and y axis. We'll consider a point at a distance r units from the center, which makes an angle theta like this. Please note that theta is measured in the counterclockwise direction starting from the x-axis. So this is how theta is measured. Alright. Now if you have several angles like theta 1, r1, theta 2, corresponding distance is r2, then theta 3, r3, so on and so forth, the graph will looks like this. First we will mark the first point. The point is theta 1, r1, which means that this distance is r1 and this line make theta 1 angle with the x-axis. Next we will mark another point here, theta 2, r2. Then we will have another point, theta 3, r3, like this. Now what we do is we just join these points using straight lines. So this way a polar graph is plotted, and you may have as many points as you need. Now we will go through some examples. To practice polar graph, let us construct a spiral. So that is our problem. We are going to construct a spiral which looks something like this. It starts at the origin, it moves something like this. Okay, let us construct such a spiral. So let us consider the first point. So we need basically two things, angles and distances. Let me represent angles with A and distances with say R. So we need two arguments, that is angles and distances. Let the angles starts at 0. No, the first point is 0. The corresponding distance is 0. Then as we move away, both angles and distances keep on increasing. So you must have an increasing values of angles and increasing values of r. Let us see how much r increases. This is the angle increases. So at this point it is 0 radian. Now it's pi radian, 2 pi radian, then 3 pi radian, then comes 4 pi. So 4 pi radian. So you must have a set of angles that increases from 0 to 4 pi, and you must have the values. Say this distance is some 5 unit and this distance is 10 unit. So the distance increases from, so this is 10 and this is 5. So the distance increases from 0 to 10, from 0 to 10 units. Now how you construct such an array? It's very simple. Hope you remember linspace available in the NumPy module. So using linspace you can construct an array from 0 to 4 pi having some 1000 points in between. Okay, so the idea is very simple. Using linspace start stop, the number of points. So we'll have 1000. So this will create the first array, that is array of angles. Now to construct array of distances, you can similarly use linspace, which we know that r must increase from 0 to 10. So 0 to 10, you must have equal number of points in A and R. So that means here also you must have some 1000 points. So 1000, correct? So this way we can create A and R. So once A and R are generated, you can use polar function, polar A comma R, to generate the required spiral. So let us see how it works by writing code in Python. So let us try the spiral program. For that I am going to generate a batch file. So a new file is taken. So I'm going to use both NumPy and Matplotlib. So NumPy as np, and then import Matplotlib dot pyplot as plt. Now I'm going to generate both angles and distances, as we have already discussed. A must be np dot linspace 0 to 4 pi, so 4 star np dot pi 4 pi. Then we will choose some 1000 points in between. Similarly, we will generate the distances r, np dot linspace, then 0 comma 4. We have chosen 10 as the maximum distance. Then we'll generate 1000 points. Fine. Once it is over, we can plot plt dot polar graph. Polar, the angle, that is A, then the distances R, then plt dot show. So let us save the file. Save as. Polar. We'll save it as spiral. Save. Now let's run the code. Yeah, you can see the spiral. So these blue lines starts like this. It moves spirally outward and reach up to 10 units. You can see that this is the distances, so it moves up to 10 units. So this is at the midpoint, that is as we expected, 5. Okay, now let us try some keyword arguments. You can choose the color as red and markers as into, then markers as into, then color as red, and the line as dotted lines. So we'll see. Okay, so into marks, if you zoom it, you can see why it is something like this. Sorry. Doesn't work. Don't know why. Okay, we will make some other alternate change. So instead of into, we'll have some circles as O. Then let's see. Okay, no, before that, let's try circles but with fewer points. So let us choose some 10 points to make it more clear. So you can see the plots. So I have chosen only 10 points. So this is the first point, second point, third point, fourth point, fifth point, so on and so forth. I used the circles as the markers, then red as the color, and the dotted lines as the line or connectors. So it is similar to plot function. Okay. Now I wish to make some other change. I'm going to add. I'm going to remove the grids. Plt dot grid false. I'm going to remove them. So everything looks like a plot function. Okay. You can have more points, say some 20 points. Here also let us choose some 20 points. So let us see how the graph looks. Okay, now you can see that we have removed all the grids. So this is how polar function works. So I can give you another beautiful example, that is polar rows. You can have a polar graph. So we will have angles theta, something like this, and we take the sine of this thing, and if you run this code, you can see some petals of rose. Okay, to make it more legible, we will remove the legend. So we'll see the graph. Something. Oh, sorry. I made a mistake. It's not legend. I mistakenly wrote it grid. Okay, now the polar rows looks good. Okay. Now I request you to try with different n values. Try odd numbers and even numbers for n and see how many petals are there. So it's your assignment. I will share the I shall share the Python code also. So you try with the different n values and see how many petals are there for even number of n's as well as odd number of n's. We have seen two examples for polar graphs. So try to run these two codes and see how the output looks like. And I request you to change the parameters and explore the changes in the polar graph so obtained. You must also try multiple polar plots, and you must also try legends, etc., which is available with the plot function. Okay. Thank you.